Now that you've learned the structure of an atom and what protons, neutrons, and electrons are, it's time to talk about how to read the periodic table of the elements and how to understand a few of the different patterns that occur within the periodic table. So if we take a look at the periodic table, it looks like this. Every one of these squares, let's just circle the first one here, every one of these squares represents the information about a different element on the periodic table. So the very first one that we find in the top left is hydrogen, which is the most common element not just on Earth, but in the universe. Now, just like we read English, the periodic table is read from left to right like this. So the next element would be over here, which is helium. And then when we get to the end of this line here, we get to the third element, which is lithium. And then we would read like this to the end of this row and so on. Now, what we're going to do is we're going to look at the information about hydrogen and understand what each of the important numbers within hydrogen's square represents. So the first and most important number is this number in the top left column, and this number here represents the number of protons that this element has. And this piece of information is so important that this is actually how we order the elements on the periodic table. So for example, hydrogen is number 1, meaning that it has 1 proton. So P is for proton, and we remember that protons have a positive charge, hence the plus sign here. If we go over to helium, we see the number 2, so that means helium has 2 protons in its nucleus, and so on. And this number is so important because of how the periodic table is organized that we give it the name atomic number. Now, once we know the atomic number, we can do a few things with this atomic number. So as mentioned previously, we can use this to identify the number of protons that exist within the element, but we can also use this number to find the number of electrons. So remember that electrons are another subatomic particle, but unlike protons, they have a negative charge and are found outside the nucleus. So we use the short form E with a negative sign to represent electrons. So on the periodic table, it is assumed that all of the atoms of each element are considered neutral. So remember what the word neutral means. Neutral means neither positive nor negative. So what this means is that the amount of positive charge that an element has is equal to the amount of negative charge that an element has. So if hydrogen is our example, we know that hydrogen has 1 proton because of this number 1 as its atomic number. And if hydrogen is neutral, that means that it's also going to have 1 electron for a charge of -1. And if we do some simple math, +1 minus 1 is 0, meaning that it is neutral. So that's the assumption for all of the elements as they're written on the periodic table. If we look to the center, we see the most obvious symbol in the center is the letter H. This is what we call the chemical symbol, and this is the shorthand that is used for this element, especially when we form compounds with it. So every compound that contains hydrogen will represent hydrogen with the letter H. For example, H2O in water, this shows that water has 2 hydrogen atoms. If we go to the bottom here, we see a number that's a decimal number. This is 1.01. So this is what we call the atomic mass. So remember in the previous video, we talked about how protons have an atomic mass of 1 atomic mass unit, and electrons are really small, so they have a mass of 0 atomic mass units. So this number here, 1.01, indicates how we can find the number of the last subatomic particle, neutrons. So if we remember that protons and neutrons have an atomic mass of 1, we can find the atomic mass by taking the number of protons, which have an atomic mass of 1, and add it to the number of neutrons, which also have an atomic mass of 1. Now, because protons and neutrons each have an atomic mass of 1, how do we end up with a decimal number here? Well, the short answer is you don't need to worry about that in Science 10. It's assumed that the atomic mass is always rounded to the nearest whole number. So 1.01 is equal to 1 for our purposes here. The last number we need to pay attention to are these positive or negative numbers here in the top left corner below the atomic number, below the number of protons. This represents the most common charge that an atom can form. Now remember that the number of protons and number of electrons are equal if the atom is considered neutral. Well, if the atom isn't neutral, it forms charges like this. So the charge indicates whether an atom has either gained or lost electrons. So remember that an electron has a charge of -1, and if we add negative charge, if we add electrons, that is the same as the atom gaining negative charge like this. But if you lose electrons, remember when you subtract a negative number, so -1 let's rewrite this, -1 minus -1, this is effectively the same thing as adding +1, so -1 minus -1 would be 0. So if an element loses electrons, this is what gives it positive charge. So the charge indicates whether an atom is going to gain or lose electrons, and therefore either gain positive or negative charge. So for example, atoms that lose electrons are going to lose negative charge, so their charge is going to become more positive, while atoms that gain electrons, that add more negative charge, are going to become more negative because you have more negative charge than you did before. So to understand a little bit of how we can use these numbers, let's try to interpret this element's data. So Ti is the chemical symbol for an element called titanium. This is used as a metal for aircraft construction. So we can find the number of protons very easily. This, we simply look at our atomic number. This is going to be 22. Now, the number of neutrons is not easy to find because it's not given directly to us, but we can see that our atomic mass, which is the number of protons plus the number of neutrons, is available for us here. So let's write 47.87, but remember that protons and neutrons each have an atomic mass of 1, so let's round this number to the closest whole number. 47.87 rounds up, so let's consider this 48. So if we want to find the number of neutrons, we would need to take the atomic mass and subtract the number of protons, 22. So if we do some quick arithmetic here, we can see that it has 26 protons. Now, if we want to find the common charge that titanium has, we can see there's actually 2. It can have a charge of +3 or a charge of +4. Now, because we have a positive charge, that means that we are removing negative charge, which means that titanium is going to lose electrons, and we can see from the charges that it's either going to lose 3 electrons or it can lose 4 electrons in order to gain a +3 or a +4 charge. In the next video, we're going to take a look at the periodic table as a whole and look at several different groups of elements that occur on the periodic table.